What's up, team? Here we go. There's a request to complete a couple problems from page 55. So we're going to do that. Starting with number 25. Here's what it looks like. I drew it out based on the description in the textbook. So we have this triangle X, Y, Z, and the coordinates were given to us. Normally, like this would be on like a coordinate plane and stuff. I kind of visualized it. I suppose if you wanted a y-axis, it'd be something like over here, and then x-axis would be up here or so. But that's not really necessary for our problem. But we do need the coordinate points. The reason I know it's a right triangle and shaped something like this is because these two have the same y coordinate, and so they're going to be, this is going to be a horizontal line, and then these two have the same x coordinate, so that's going to be a vertical line there. So we know that our triangle is going to look something like this. Of course, it's not exactly to scale, but it's, close-ish. So the question here asks us to find the perimeter of this triangle. So what that means for us is obviously we're going to use the distance formula. That's the whole topic here. But what we're going to end up doing is we're going to use the distance formula 3 different times. We're going to use it to find xy, we're going to use it to find yz, and then we're going to use it to find xz. And once we find all 3 of those distances, we're going to add them together, and that's going to be our perimeter. Okay, so let's dive in and see what happens here. So xy is where I'm going to start. So that's these 2 points here. I'm going to call the x my x1, y1, and the y my x2, y2. In fact, actually, before I even dive into this, I encourage you, now that you kind of know what we're getting ourselves into here, using the distance formula 3 different times, I encourage you to pause the video, solve it on your own, and then come back and watch the video and check your answer with my work. Assuming I'm right, I'm going to do my best to be right. We'll see what happens here. But I encourage you to do it independently and then come back and verify. I think you'll learn more that way, even if you make mistakes. Mistakes are a good thing. Mistakes is how we learn. Okay, so xy, here we go. So this is my x1, y1. So what we're going to do, let's see if I can fit the whole formula up here. x2 minus x1. So that's going to be 21 minus -3 and squared plus y2, which is -6 minus -6. Gross. That's going to be kind of confusing, but we'll make it work. Okay, so that is going to equal 21 minus -3. That's going to be a plus. So it's going to be 24 squared plus, well, -6 minus -6. That's also an addition problem. So that ends up being -6 plus 6, which is 0. And then just for kicks and giggles, we'll put that 0 squared there, even though it's just going to go away. Now, at this point in time, we really just have the square root of 24 squared. And if you recall, square rooting and squaring are inverse operations. It's kind of like how multiplication and division are opposites of one another. They cancel each other out. The same thing is true here. So the square and the square root are going to go away. And we learn that this has a distance of 24. So let's capture that. Let's get it written in so we don't lose it. So this distance here, xy, is 24. Okay, 2 more times. YZ is next. YZ. So same thing. This time, I'm going to keep going in alphabetical order here. So my y is going to be my x1, y1, and my z is going to be my x2, y2. So here we're going to go 21 minus 21. We see where that's going. That's kind of cool. Plus, now it's going to be 4 minus -6. Boom, boom, squared. 21 minus 21, that's 0. This time I'm not going to write it in because we know what's going to happen here. Now 4 minus -6, that's 10. So we're going to have 10 squared. I'm going to jump. I'm going to do a couple steps in one here. 10 squared is 100. And then, of course, the square root of 100 is just 10. I could have done the same thing here. I could have written 10 squared, the square root of 10 squared, and then canceled them out. The same process would have worked. I just got ahead of myself, and I really wanted to write down 100 for some reason. But it's either way, you're going to get 10. Okay, last one. This one, we're actually going to have to go through all of the steps. Nothing is going to cancel out the way that we hoped it would, or the way that it did on these first 2. So I'm going to give myself a little bit more room here. So this is going to be x, z, and we're going to have the big square root, big radical here. Let's see. Okay, again, I'm going alphabetical. So this will be my x1, y1, x2, y2. So it's going to be, for the x's, 21 minus -3. Boom, boom, squared. Plus, now it's 4 minus -6. Boom, boom, squared. Okay. Let's put the equal sign there. 21 plus 3, that's going to end up being 24 squared plus, that's going to be 10 squared. interesting how we use the same numbers here, but now it's the 24 makes an appearance again, and the 10 squared that I probably should have left as 10 squared is making an appearance here as well. It's kind of fun. Okay, let's find out what 24 squared is. I don't have that one memorized, so calculator 24 times 24, and I learned that that is 576 plus 100, because that's 10 squared. So adding these together, that is going to be 676. So I need to find, well, let's write that out. All right, that's going to get a little messy. So we're finding the square root of 676. So in my calculator, square root 676, it tells me that that is 26. So that means the hypotenuse to this thing is 26. Okay, now we are just doing some addition. This is the fun part. So we're going to take our 24 plus 10 plus 26. When we add these together, 20, 40, 50, that's going to be 60, I believe. 60 units. Boom, boom, boom. There it is. So this is the answer to number 25 on page 55. Okay, here's number 26. I didn't draw the picture, but I took away the important pieces of it, so that the pieces that we need. So I looked at this point, this line segment AB, and I wrote down the endpoints. So A is at -2, 3, and B is at 3, 1. Those are the important things about this line segment here. And I did the same thing with CD. C is at -4, -4. D is at -2, 1. Our goal, our mission, our aim for this particular problem is to show that AB, so segment AB, is congruent to CD. That means they have the exact same length. So all we're going to do here is we're going to use the distance formula with these 2 points, AB, and then we're going to do a second time, we'll use the distance formula with these points, CD, and if they have the same length, then the segments are congruent. If they have different lengths, the segments are not congruent. Let's see what happens. Okay, so for the first one, AB, let's get back to labeling these. Let's get used to that. So x1, y1, x2, y2, and then the same thing here, x1, y1, x2, y2. I know that seems annoying to do it every time. I'm doing it from experience because I just lose track of things. Maybe you're more organized than I am, but I have to do that, otherwise I'll get all mixed up. Okay, so AB, the distance formula here, so it is square root of x2 minus x1, so that is going to be 3 minus -2 squared plus 1 minus 3 squared. 3 minus -2 is 5. 5 squared is 25, so I'm going to jump straight to the 25. Now 1 minus 3, that's -2. -2 squared is +4. So we learn here that AB has a length of the square root 29 units. That's not really fun to look at or talk about, but that's what it came out to be. So we're going to hope that the other one does too, and if so, then they're congruent to one another. Let's find out. CD, again, big square root, x2 minus x1, so we have -2 minus -4. This is funky, so it's a negative, and we're going to add, and it's going to end up being positive here, and that's going to be squared. And then the y2 minus y1 is 1 minus -4, boom, boom, squared. Okay, -2 plus 4 is what this turns into. That's going to be +2. +2 squared is 4, plus 1 minus -4, that's going to be 5. 5 squared is 25. Oh, hello, I see where this is going. We ended up with the same things here. So 4 plus 25 is 29, so the sum here is 29. And we learned that, boom, they both have a length of root 29 units. If that feels uncomfortable still, you don't like how that wrapped up, let's throw that in a calculator. We type in square root of 29, we click the equal sign, and that's 5.4-ish. So show that they are congruent. They are indeed congruent, and they each have a length of approximately 5.4 units. Okay, hey, I hope this helped. Let me know if you have more questions. I'm happy to help. I'm happy to create these videos anytime. Just tell me what you need. We'll make it happen. All right, have a wonderful rest of your day.